I don't have a clear idea on what to talk about. I'll just pose some questions I have been thinking about lately. One question I have been thinking is can certain parts of science be reduced into the more fundamental part? The current consensus is that people think all the empirical and natural science, there seems to be a hierarchy. So typically, people say the king, the mother of all science is physics, and then physics as the underneath layer. And of course, you could argue underneath physics there's mathematics, but mathematics is not really an empirical science. You could argue it's a kind of axioms, it's a kind of rules humans being set up. You could argue it's a formal science, but nevertheless, physics is widely regarded as the fundamental layer of empirical science. And then on top of that, you have chemistry, how matters in the entire universe react together. And then on top of that, you have biology, which is much more a smaller scope of science compared to chemistry and physics, because chemistry and physics have no boundary within Earth. It expands and transcends beyond Earth to the entire universe or even multiverse. Biology seems to be confining within life, biological organisms, and so far, the only place that happens to breed and nurture life is only Earth. So biology seems to be slightly, you could say it is more specialized, you could say it is more subsidiary, more derivative, hence it is not so fundamental. And of course, you have geology, things like that. So the question I've been thinking is, for example, can biology be reduced into physics? What does it mean? Because I was thinking, right, if every single thing is made up of atoms and particles, and in physics, even in chemistry, we tend to have this belief that there is clear cause and effect. You add three mole of sodium bicarbonate with 5 mole of another solution. You could work out a calculation and you would get the end product. It seems to be very deterministic, and likewise physics is even more. You can do the mathematical calculation and predict the movement of objects, and hence if everything is made up of atoms, matters, and particles, and if physics and chemistry have shown that you could determine the end outcome of a reaction so deterministically, right, then biology, then all organisms, particularly us and human beings, our organs, the cells on my entire body, are also made up of atoms, are also made up of particles. Then they should be following the same law. You could use very linear calculation and model to model the entire body, and therefore you could extrapolate and predict how your organs react, by when your cells would all die and you will die. And of course, you could figure out how could what caused and when will you get mutation of cells to cause cancer, all those kind of things. So that should be possible, right? And in philosophy of science, this kind of intention is called reductionism. People, especially the physicists, they are very excited. They have this grand dream of unifying everything. That's why there is a movie about Hawking. The name is called The Theory of Everything. So particularly physicists, they have this grand dream of unifying and reducing everything. Reduce all biology into physics. You could and reduce all chemical reactions into physics. Because currently, if you look at chemistry textbooks, most of the theories are still confined within chemistry. So, for example, you talk about hydrochloric acid being an acid because it has a pH value of 2 or 3, because it has a certain amount of hydrogen plus ion, and then mix when you mix hydrochloric acid with another base, it will produce a salt at the end. It's a neutralization. But however, in chemistry currently we are stopping there. We treat acid plus base producing salt as axiomatic. We don't really go further into subparticles and ask, oh, which part of the atomic structure of acid causes the atomic structure of base to react together and form a salt. So chemists or physicists haven't really cracked that. So this is an interesting part, and currently, I think I've read on Reddit. It's very interesting. I think 30 to 50 years ago, reductionism was very popular. People wanted to unify everything, but recently, probably for the last 10 years, reductionism has gone out of fashion. People don't believe it anymore. Partly, it's very difficult. There seems to be no progress, and secondly, there's a new ethos. The new ethos is that in general, actually the demarcation, the categorization of science into physics, biology, chemistry, geology is actually quite fictional, quite artificial. It is human-made, because if you look back 1,000 years ago, the first study of nature was just called science or even philosophy, like Aristotle, Plato. So people didn't consciously divide things, and actually there is no hard and fast rule to divide things. In fact, the division of physics, chemistry, biology, geology will likely happened likely because of expediency, I believe. It is much more efficient to specialize, but however, we have to really zoom out to the highest level and be mindful. At the end, it's just the study of mere nature, and it is not clear if you because if you talk about philosophically, all of us as human beings were being thrown to this world in this tiny planet. We are kind of stranded, but it's like a game character being thrown into a game arena, and we probably don't have too much power to change the rules of the game. We could just slowly explore and find out what is the border, what is the ground rules of the game, and then from there on, if we understand enough, we could probably try to change it slowly. And likewise, science is merely a game. I think science is merely a game where humans are the game characters trying to figure out the rules, trying to figure out what are the borders. Hence, there's no reason the artificial division of physics, biology, and chemistry. Why all this artificial division? There's no reason why one of them could unify, could explain the other. There's no reason why some of them could be reduced into one another, because that sounds a bit odd, right? Your own division, then you want to use your own division to devour your another division. That seems a bit preposterous. So this is the current ethos. The current ethos is that people don't really believe in reductionism anymore. So a lot of biologists, this is what I read on Reddit, yeah. A lot of biologists or even geologists, they don't think too much about what is underneath anymore. So if you talk about evolution, you could probably theoretically model using physics the entire billion years of evolution. And of course, if you have very powerful mathematics and also very huge database, you could eventually compute and mathematically and prove, oh, why did mammal evolve from reptiles, for example. You could do all those kind of mathematical model, but however, the problem is the sample size is simply too big, and therefore I think generally biologists are not trying to do that as of now, until one day we could have some breakthrough in mathematics, maybe a powerful computers, we could do that. And likewise, the modeling of cancer. Why does a person get cancer? By when he or she get cancer, which part of the organ will mutate and get cancer? It's very hard to model. It's possible. Again, your human body has millions of cells. It is possible to model them, compute them, and run a simulation using mathematics to reduce biology into physics, into mathematics, to clearly predict and explain why a certain part of your organs mutate and get cancer. But however, again, the sample size is too big. Currently, people are not able and seem to have given up on that. Maybe not giving up. Maybe they're just temporarily giving up. It's like putting a temporary pause. Maybe they will come back on this someday in the future when we have a powerful computers, when we have a new kind of mathematics. Yeah. So this is something I wonder. Yeah, because if we could really reduce things into definite cause and effect, we would have much more control. At the very least, we could control aging, we could cure cancer, we could be able to cure all the old age diseases such as Alzheimer, Parkinson, dementia, all these kind of things. Yeah. So this is something I think about, but furthermore, I would like to segue a little, but actually it's related. If you want to reduce biology into physics, right, then you have to first ask the question, where did life first emerge? This is a very important question in philosophy and science, very hard to answer, because if you look at how vast the entire universe is and how tiny Earth is, why would the universe have only one tiny spot that has life on it? It's very mysterious. Currently, the popular explanation is that, okay, of course, after Big Bang explosion, all the Milky Way galaxies were forming. Then you have the solar system formed, and then all the dust and matters coalesced and formed planets. And then, odd enough, Earth being in a position not too far away from the sun, not too near, and it was able to synthesize water. Alright, the origin of water of Earth is also unclear, but the existence of water prompted the first life, the first simple unicellular life. Charles Darwin called this the last common ancestor of human beings. And I don't know what is it. Maybe it's some eukaryotes, some prokaryotes. But currently, the general belief, the popular explanation of the first life on Earth is the theory of abiogenesis. The word "a" implies that it's like moral and amoral. So abiogenesis implies that we didn't need a real life to synthesize life. The first life was synthesized mechanically, unbiologically, using unorganic matter. So there's this famous experiment called Urey-Miller experiment that proved and showed that by combining a few unorganic matter in a right temperature, right condition, you could synthesize a unicellular organism. And after that, the rest is history. We have multicellular organisms, we have fish, birds, reptiles, mammals, and us today. So this is the short explanation. I'll stop here. I'll continue tomorrow. See you.